Hey, everybody. Okay, so I know I'm a little foggy here, dark in the corner, but I want to catch you up on a few things. I just wanted to go through a few things in the news we've been discussing here in the live classroom. One was the climate summit that just happened in Paris, and I was quite encouraged. I didn't see a whole heck of a lot of it, but it really looks like, so the governments are now, it appears at least, doing the right thing, doing what they need to do in terms of acknowledging the climate crisis that we're facing and realizing that's not something that is off in the distant future somewhere where no one's going to really care about planet Earth, but it's something that could very drastically affect the next couple generations of people on this planet. Another thing I saw was that it looks like some wealthy individuals, so not only politically influential people, but some very financially influential people like Bill Gates were there too, announcing funding to go into renewable energy technology. And really they're just looking for innovation. Like here's some money. I've already solved my problem, creating microcomputers, et cetera, and now let's take some of that money and reinvest it in planet Earth. I think it's what it comes down to, rather than just continuing to exploit it, take the natural resources out, sell that for some money, use that money to re-exploit natural resources, and never give anything back. So I was very encouraged by that. Another thing, a couple people asked what I'm up to this week. So as you know, President Engstrom announced his desire, will, plan, whatever, to remove my tenure line from the University of Montana along with the energy technology program. So he does not feel like the energy technology program is, I don't know, pulling its own weight, or I'm not sure. I haven't, last time I talked to him, there was no mention of this to me. But one thing I am interested in doing is, it's strange because I have the National Science Foundation paying us $250,000 a year to do what we're doing. I also have received a pledge from the Missoula Federal Credit Union to provide funding for our program, along with several other local philanthropists. So it's still a little puzzling to me why Maine Hall would not see value in a renewable energy technology program like ours. To that end, what I'm going to do tomorrow to the Missoula, or it's called the Five Valleys, and I'll Google it here for you. Five Valleys High Performance Building. Let me see if I can't find my message from my buddy Brett here. One quick second. So I'm going to give a talk at the First Interstate Bank to Brett Rosenberg and his colleagues. Let me just get the full title here. There it is. Five Valleys High Performance Building Collaborative. So this is as you can see, Brett has his LEED certification, and he's gathered together other people from the Climate Smart initiative here in Missoula, architects, real estate brokers, some HVAC guys. I know Tom Javins, who used to be our head of HVAC here on campus, he's a member as well. Sherry Peacock, our former sustainability coordinator, is also a member. And really the idea is to, well, and we'll see how much power or influence this group has, but what I see their role is showing that Missoula, the Five Valleys, can actually produce, build, make, sustain buildings that actually meet energy requirements for the coming future. And what I'm going to propose to them is to take my house, 8 Columbine, and turn it into a net positive house for solar, electricity, heat, water, soil, and also at the same time be a carbon negative landscape. So that's what I'm going to do tomorrow. Let's see if I can actually find their website here. And they meet every first Wednesday. Maybe Brett does not have a website. I'll ask him tomorrow. So here's the Climate Smart Action Plan. Let me see. Yeah. There we go. So green building, finance experts. That's why I've asked Jack Lawson to be there. One of his real estate financiers at Missoula Federal Credit Union knows a lot of this technology already. I sat in his office, Jared and I, and I'll propose the ideas to him. But the idea is you put the money in now for a building that does not consume the Earth's natural resources later. You're not consuming coal to make electricity. You're not consuming natural gas to make hot water and heat. The whole transportation thing is a little tricky. Half of my garage is dedicated to a bicycle garage. I've got a full set of tools, repair shop, etc. It's a little like free cycles in there. I would also like to be able, with my house, to distribute excess heat and cold. So I'd like to do seasonal thermal storage. In fact, Jason was just here talking about how some of these larger scale plants are going to use liquid CO2 as a heat exchange media, so you're sort of pumping that stuff underground, if I understand correctly. I'd like to do something similar where I've got a large heat reservoir and a large cold reservoir under the house. So right about now, I'd like to be banking ice underground, giant block of ice, so come June, July, August, that's where the cooling for your house comes from. I'd love to get rid of my fridge. Just, we used to do the root cellar thing. I'd love to have, okay, you want to get something from the fridge? It's in the basement. next to the giant block of ice that we made last January, et cetera. So those are, pretty advanced, maybe a little too aggressive, but I'm going to throw it out there because that's what we get to do in academia and let the folks with the money see if they want to buy it or not. Okay, openly shares knowledge and work together for a better environment. Overcome barriers and to mainstream energy. I'll also talk about the whole zero waste thing as well. So that's tomorrow. So if you can make it, that'd be great. And we're going to meet at the top floor. Let's see. Let's just go to Missoula. Maps. I'll show you where we're meeting if you're interested in coming. Zoom in a little bit here. Okay, so here's Higgins. This is the Wilma, and this building right here is the First Interstate Bank. Let's see if I can find a street view.
101 West Broadway.
Is it 101 West Broadway?
Yeah.
Nice. East front, there we go, yeah.
Oh, that's my old back.
Anyway, we meet on the top floor of that. Locations. Hey, how's it going, Sean? Pretty good. So anyway, it's right here. How does the street? Let's see how the street view works. Wow. Whoa. Okay. Doesn't this just make you spin, or do I have, oh, I drag it, don't I? Do you guys know the, rotate the view? This is new. Oh, there it is, right there. From the belly, yeah. So this is the Higgins Bridge, and there it is. Okay, so that's tomorrow. Anything else? Just a little bit of update on the news. Let's go ahead and look into the forums as well. I will talk a little bit about hazmats today, and then I also want to just wrap up just a few last instructions on the report formatting. What I'd like to see. I think we did a little bit of review, so just so that all gets done. Job forum. Tynan found this, so there is a recycling job or two in Missoula. So recycling office manager at Pacific Steel and Recycling. The other one is for IE, so that's Martin No Runner, my pal. It sounds like he's looking to expand a little bit. Driving, sorting, loading, recycled materials. There we go. Hey, Tynan, thanks. That's some really good news. One for Pacific. One for IE. So that's good news on the job fronts, especially in recycling. Yeah, one thing that unfortunately came out of one of the more recent Board of Regents meetings is, I proposed having a recycling technology course here because I think it is, I know it is in high demand, and I think it will be in increasingly high demand in the future. But when the former dean presented the fact that we are going to be offering a recycling technology course to the Board of Regents, they were not overly enthusiastic about it. They did not think, well, anyway, they're like, what's wrong with the landfill, basically, was the unfortunately, the overwhelming opinion from the Board of Regents. Okay, but seeing those two jobs open is encouraging for me. Oh, one other thing, I've got another student, he was my intern. His name is Nathan Hansen. Let me find his email too. This will be good. This might be a great opportunity for the course too. I just remembered while we're talking about news. Nathan Hansen, I might have mentioned before, he's a third-generation garbage man from Butte, and he and his father would come home from a long day, and his grandfather, and sort of just bemoan the state of the world and wonder why so many valuable artifacts, materials, what have you, just go to waste. And he's actually doing something about it now. Thank you, Nathan. He's an inspiration to me. So here's Nathan. I told him I'm not going to be able to be in Butte, but what's he's trying to do? He says, we're looking to shoot a mini documentary for Re-Industries. That's the name of his company. See if I can find the whole thing here. So this is his company's title, Re-Industries, and he wants to do a Kickstarter campaign. So he wants to film testimonials, what have you. The technology he wants to develop is a landfill mining robot. So he would like to just go into old landfills and pull out everything, essentially. In fact, I don't know if you heard the news, but I think Montana's last gold mine is closing. It's shuttering its door.
My first mine up at Blackfoot.
That sounds right. And a thought that came to me is that if you've already, and I think it's an open, is it a strip mine? Is it an open pit mine? I don't.
I'm not sure. I think it is. I think they do. Well, I know there's a lot of tailings that ended up in the Blackfoot River.
Yeah, yeah. It's just a thought, and I don't, it seems like initially these mining companies must have gotten some kind of permit to do the mining, right? So they had a permit. They said, okay, it's environmentally safe, whatever. So if they got the permit, why not do your urban mining there? So send all your electronic waste, send those precious metals back to the hole they came from, reinvigorate that workforce, and let them smelt, melt, what have you, the materials on site, because that area has already been dedicated. If it's not, if that really is not an appropriate place and needs to be returned to nature, then let's do it. But I'm just trying to, think of how to preserve those jobs and allow people to continue mining. Just let them mine through the mountains of electronic waste that we create all the time. So, yeah. Okay. So that's news item number 2. Nathan Hansen, thanks for doing that. So if anybody in the class is interested, we'll get you in touch with Nathan. And then I just wanted to catch up on all the posts. I figured I would do that publicly here. Let me see what Priscilla is saying here. I don't know if I understood correctly, but in the beginning of the video, it is spoken that this process can just happen after reuse and recycling processes. So why is it responsible for this pre-work? Do they separate the waste that contains heavy metals? Do you understand what she's asking here?
What was the
Oh, yeah.
Oh, how the world is going to end.
Well, so maybe she is talking about the entropy video, and my vision of this thing. I mean, it's a great question. I'll just try to answer it generally, and this is similar to what I've been talking about and what I've been seeing lately. So if you have your waste stream coming in, and this is applicable for the hazmats that we're talking about right now too. So you've got your waste coming in, and more than likely it's coming in, by rail, by truck. If Elon Musk has his way, it'll be sent by evacuated solar-powered hypertubes. Who knows? Or maybe it's a drop-off station. Drop-off. Anyway, here comes your materials, and it's mixed, right? There's sort of everything in there, and then the 3 basic categories. So this is getting back to Priscilla's question: is how's this reuse and recycling project? What's the pre-work? How is it separated? There are 3 fundamental categories. So you can either apply thermal energy, you can provide chemical energy, and you can provide mechanical energy. And I think I even put a test question out there. Yeah, so that's where I was going with that. And there's not nuclear. What else? It could be electrical. You could imagine, and in fact, that's more or less how aluminum is made. That's how the aluminum atoms are separated from the other atoms in an aluminum smelting process. They are electrostatically moved in a big ingot. So electric to some extent. It might, yeah, it might even coincide with magnetic. I'm running out of space here, but yeah, magnetic would be, pulling the iron, pulling the ferrous materials out. Each one of these requires energy. The magnet is kind of special, I think, in that it's actually conservative. And I don't know if you know exactly what I mean by that, but let me tell you, this is actually quite important to think about in any renewable energy efficiency operation. So let me give you a mechanical analog, and there are two here. So if I've got a wall and a floor and a spring and a mass. I know that this mass can move back and forth, and I know that the spring can stretch. So the mass has mass M, the spring has some spring constant K, meaning the harder I pull, or the farther I pull, the harder it pulls back. And then the third thing is I've got friction right here, and I'm just going to call that mu. So that's it's just a fundamental mechanical system. In that system, two of those things are conservative and one of them is non-conservative. Can you tell me which two are conservative and which one is not? Without really knowing exactly what conservative and non-conservative. Just take a guess, though. So the spring and the mass are both conservative. If I were to take that system and turn it like this, and here's gravity, it's going to sit there and bounce up and down all day, right? I give it a kick, I give it a kick start, boing, 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 boing. It's going to lose some energy, and there is some friction. Where's the friction? Well, it's kind of everywhere. There's air friction, there's molecular friction in this guy. So K and M are both conservative, and mu is non-conservative, meaning that its energy goes into heat. But that isn't coming back, right? I mean, you might put this inside a building and use the waste heat for something, but once you've sort of made something hot, you're done. You're not going to get that heat back, really, to do work anyway. Okay, so I like the magnetic idea because a magnet is also conservative. So if I had a jar and I put let's just say I put a magnet here at the bottom, and I put another magnet up here, and they were opposite polarity, it would just sort of sit there and bounce back and forth all day long. The only way those magnets, the system loses energy is again to friction. So what I'm saying here is any time you can use a conservative form of energy rather than a non-conservative, it's going to be better. It's going to be more efficient. The thermal, obviously, that's non-conservative. You could take the heat and turn it into district heating. Use it to keep the house warm, keep the driveway from freezing over, what have you. Typically, chemistry is thought of as non-conservative as well. And we talked about this a little bit. And this is also very critical in terms of hazmats, because any pure material in general is going to have a higher value than an unpure material. So if I'm going to go make copper wire, I'm going to want the purest copper possible so that I've got really low resistance. Same thing with aluminum. If I'm going to go and make a titanium airplane, I'm going to want to buy very pure titanium so that when I go and mix my chromium and vanadium with it, I know I've just got titanium in there, not steel or something else that's going to compromise the properties. So a chemical process is usually one where two pure substances come together, they get hot, and they come out as some kind of mixture or compound that is typically not as useful. So you tend to think of chemical processes as being non-conservative. Of course, there are reversible chemical processes. Biology is a great example. So like the carbon cycle itself is reversible. So CO2 is exhausted by plants, or sorry, CO2 is exhausted by animals. It's then metabolized by plants, sort of back and forth. So that chemistry is sort of perpetuating. It takes solar energy to come in, which I guess we might as well mention. That's radiation. And I think in a lot of ways, you can think of radiation as being non-conservative. You know, once a photon has hit the planet, it's done. You know, its energy is still there, but it's not going to hit the planet again. There are a lot of plasma technologies coming online right now for dealing with hazardous waste. So plasma will disintegrate a substance to the point where there's just electrons floating around. I mean, you've really even destroyed the not just the molecular structure, but you're destroying the atomic structure as well. So you've just got protons, or individual nuclei and electrons flying around in this gas, which makes and I haven't written it down yet, which makes a gravitational, which is also a conservative process, that much better, because now you have something that's hot, light things go up, heavy things go down. That's basically how the petroleum industry does their song and dance with their distillation columns. So you've got that gravity working for you, but now with in a plasma radiation context. Mechanical, this can be conservative or non-conservative. That's kind of why I like the mechanical disciplines. Non or con. And so and I just showed you an example. Dragging something around with this friction coefficient mu is non-conservative, is turned to heat, but a spring system is conservative. So, you know, one really simple idea for thinking about moving moving matter around. I mean, if you had a table and you had a box here, let's just say somebody was, you know, sorting through this box, or a machine was, and you had to move it, it would be much better to put the thing on wheels, right? Because you've reduced the friction coefficient. You've reduced the amount of energy that has to be used to move it. We see that in conveyor belts all the time. Another that I haven't seen, but I think that might be a lot of fun, would be an inverted pendulum. So it's kind of cool. You know, we in fact are inverted pendulums. I don't know if you're thinking about it, but any bipedal organism is just walking around to, you know, upside down grandfather clock pendulums. But here, what you'd have would be, you know, materials going into this bucket. You push it over here. It has to overcome a little bit of gravity, but it just sort of rocks back and forth between these two things. You know, however much up you give it, you're going to get that much down once you've crossed this little peak or threshold. So inverted pendulum would be another kind of cool way to use the conservative mechanical, you know, you've got a hinge combined with gravity. And then electrical, this is a tough one too. And let me just show you, just to complete the thought on systems. So in a mechanical system, I'll just circle this guy. In a mechanical system, the three main components again, are spring, mass, and friction. And in an electrical system, and you guys better get this one right. So you've got your battery here. You've got some resistor here. You've got a capacitor. And then you've got an inductor. So LCR, those are the three fundamental components of an electrical circuit. You're probably learning that in AC already. Which two of those are conservative and which one is non-conservative?
The load is not conservative.
Right. So these two guys are conservative, and this is not. Why is that? Well, because heat comes off. In an inductor, it's just a big old conductor. I mean, sure, there's a little bit of resistance there, but the electrons just fly through that inductor all day long, and as long as the resistance is sufficiently low, we consider that to be a system that does, a component that does not lose energy to heat. Same thing with the capacitor. It's just a bucket. It gets filled up and emptied, filled and emptied, filled and emptied with, relatively modest resistance. So if you can design a recycling system that just, and so again, I'm going to say non or conservative, depending on what's going on in the electric. If you can use a system that, bounces, if you will, bounces with your inductor and your capacitor, then you're not wasting energy to heat. But maybe you want to. Maybe you do want to get something hot. We did this a few years ago to boil water. I mean, that's a fantastic example of using an electrical circuit to make heat, to boil water. Make your toast in the morning, what have you. Okay. So Priscilla, I hope that answers your question. And I hope I also talked a little bit about hazmat in there, because that's really where we're going to see a lot of innovation here on the horizon with recycling, is using plasma and taking advantage of the fact that waste comes in. It's going to undergo, and I just added a whole bunch of different processes here, didn't I? Thermal, chemical, mechanical, electrical, magnetic, radiative, gravitational, and then over here, you will have, and I think I showed something similar, and I'm just going to write a few things up. Everything comes out. Here's your lead, here's your mercury, here's your silicon. Depending on how much heat you hit it with, maybe up here's your methane again, your ethane, etc. So that's just the overall strategy for what's really known as a MRF. We haven't really talked about MRFs much, have we? Yeah, let's do that. One of the gals that I sit with on the zero waste bucket in Missoula has led some MRF efforts. MRF. And there are right ways and wrong ways to MRF something. There's a famous landfill in Manila that is a home to a few thousand people. I don't know if you've heard of this thing, but every once in a while, like a few hundred people just die. They'll be literally buried in garbage because they're there extracting materials that the rest of the Philippines was wasting. It's made the news a few times. But all right, I gave my $3 already. I think Wikipedia should be smart enough to know that. Yeah, but let's take a look at it. So Materials Recovery Facility, or MRF, a specialized plant that receives, separates, and prepares recyclable materials for marketing to end-user manufacturers. So really, we're right back to that first lecture we gave early in the semester, and we're turning that upward left-hand corner on the recycling symbol. Let's just take a look at
that.
this.
What they've got up in BC, basically.
Yeah. The gentleman I spoke with yesterday, and we didn't have time to go through all of his technology, but Yeah, they recover everything. Zero waste. Zero waste. So here it comes, paper, plastic, metals, et cetera, et cetera. This takes the burden off the homeowner, right? So like, there it's going. See you later. Magnetic, so I like this one too. Air sorter, of the technologies we talked about, where's air on this one?
Or mechanical.
Yeah, there's some electricity going in, but it's a mechanical system. And so the lighter stuff, the plastic bags, the dog dandruff, the whatever is flying up here, going through some filter. But then again, once in a while, you're going to get some little tiny chunk of gold. Somebody spilled some Goldschlager on the floor during the party, and then the housekeeper came and vacuumed it up. The vacuum bag went in the back of the garbage truck, and now your Goldschlager flake is in your Murph. And whoever owns the Murph owns the gold. Okay. Metal, cans, heavier plastic. Here comes the paper. Glass is heavier, so it's coming down. Off comes the iron, stone, ceramics, hammer mill. There's Thelma and Louise right there at the Murph hanging out. Another air blower. So now you've got hammer mill. This is also mechanical. Most of this is mechanical. We did see an example of the iron coming out magnetically, but they're just hitting it again and again, and really. No reason why you couldn't take the same, down here, like, what's left over? A lot of that could go into a waste to energy, if there's still a little bit of hydrocarbons in there, turn it into energy, or just give it another shot, send it back through again. Where's the harm? It's a infinitely regressive process.
What about all the foodstuffs?
Yeah,
Biomass?
Yeah, that's a good question. I don't see this. I'm hoping, and I think, if I understand correctly, 7 states are actually going here where biomass is no longer allowed in the landfill, and this is basically the landfill. So I think it's also going to be a law that. Restaurants and grocery stores are no longer allowed to throw away their excess food.
We'll have to have a separate service?
Yeah.
Separate service.
Yeah.
Good.
Yeah. So I think, Brian, to ask your question, probably minimal biomass going in here.
So this is assuming the homeowner has done the triage?
Yeah, it's assuming that the homeowner is at least done a dual stream. Done solid waste, what we're looking at here, and then a biomass. So we could think of this as the technosphere. So this is the technosphere being sorted. The biosphere is getting sorted somewhere else. Yeah. Cool.
Easier said than done.
Well.
Remnants goes in, burn it for use.
Yeah.
Well, they're composted.
Yeah, compost is just kind of a slow burn, isn't it? It's still, yeah,
Well, but
metabolic burn. Okay, so I think I've kind of gone over there a little bit on the forum catch-up. There's not a whole heck of a lot else going on. You can take a peek at these other ones. 1, 2, 3, 4. I've got 4 that are unread. I can go back, or no, 7, I guess, total. I can go back and we can check at those on Thursday. But I'm highlighting hazmats. Anybody interested in doing hazmat for their research? In some ways, you might have to worry about it a little bit with the big belly, the earth tub. What if somebody does chuck their cell phone into your compost bin? It's not impossible.
Piece of aluminum.
A chunk of aluminum, something you really don't want in your garden. Yeah,
glass isn't so bad.
Glass wouldn't be the end of the world, but anything that's got heavy metals in it.
Doesn't actually work.
I've been